Welcome everyone to this talk on traditional spar making and AutoCAD. I suppose we'll start at the beginning, and the idea was we'd build make a mast for the Naomh Crónán, a new mast, as there was some problems with the old one that was getting a bit tired, and there was a few spots, so we decided to build a new one. We thought of a few things. We initially thought of the bird's mouth method, and then on advice from Joe Pennington, actually from the Isle of Man, we decided to use what I'm calling a sandwich method, where we actually basically sandwich two pieces together. Now, to get this done, spar making, as in traditional spar making, is you go to the forest, you cut down a tree, preferably in the winter when the tree is not growing, and you're always looking for a straight tree and a long tree. In our case, we needed 41 feet. And this wasn't a possibility, so we decided we were going to laminate something up. First of all, to make a hollow mast, to make it light. And there was two ideas behind this. Number one, that it would be lightweight, and number two is that all the wiring could be internalized within the mast and tidy things up. So now, to do this, I would normally do this at home. I would normally do this on maybe a few sketches on paper, and everything would be just calculated out on a square piece of timber. However, I decided to do this in AutoCAD, and the beauty of AutoCAD is you can actually do everything in sections, and you can print it off, and if you're working as part of a team, you can actually give all that information to the team, and everyone has access to it. So this is how we started. So this is what it looked like. This would be the page one, so it would be the overall dimensions of the mast. So it was 41 feet in length, and then we broke it up into 6-foot sections and things like that, and we put in positions like the hounds, and again, everything is in feet and inches. I normally work in feet and inches. While I am comfortable with the metric system, I was trained in the inches and feet, and I still find it easier to work with. The beauty of AutoCAD is it can do both. So this was the initial drawing of the first page of the drawing, and with all the details. And then, so what did we use? Now, being a woodwork teacher, some would say in my spare time, although I would say in my full-time position, I teach woodwork, and one of the timbers we use in the school is actually softwood. This is actually an actual slide from my classroom, and I must now insert a picture of the Naomh Crónán's mast into this as well. So Douglas fir is a softwood. It grows in Ireland. It can be quite clean. You can get it can be quite clean. However, if you do get one that is knotty, it can be very knotty. When it dries, it's very stable. There is very low movement compared to a larch, for example, and it's also very rigid, very stiff, and it's also a very beautiful timber. It's very nice. It's often used in furniture, and it's often used in boat building. It's actually a very great favorite of mine because of its stability and its lightweight. So, okay, now, so we'll move on. Now, so how did we begin? Well, I suppose we started in a shed workshop, which is I must say was a fantastic amenity to have. And seeing as the weather wasn't great at the time. So in the summer, we had bought timber. Paul and the lads from the Crónán had bought timber from a man called David Hyde. He's based down in Achram in Ballinasloe. And we bought Douglas fir was bought, and it was about 24 feet long and 10 inches wide by 10 inches deep. And it was a very good quality Douglas fir. We had picked it at the time, and we were very happy with it. So this was left in the Stefan's workshop over a period of time. And so in November, I believe it was November 2019, I believe we started working on this just after the midterm break. So a few things we had to do. As the pieces were 24 feet long and the mast is 41 feet long, obviously we had to join them together. So this was done by scarfing. So a scarf joint is basically a long joint. And the rule of thumb with any scarf joint is that it's 12 times the thickness of the timber. So for example, if you had a piece of timber that was, or a piece of wood that was 1 inch thick, then your scarf joint would be 12 inches in length. Now in this case, this was timber was 5 inches in depth. And so we'd have ended up with a 5-foot scarf, which I felt was probably a bit too long. We probably didn't need that. So we came down to 4.5 feet, which was a bit of a compromise. Now, why use a scarf joint? Now, the reason you use a scarf joint is very simple. If you butt joint something together, you have a reduced gluing area. However, something like a scarf joint, you have a massive gluing area. And the bigger your gluing area is, the stronger, obviously, your piece of timber will be. So that's why so here we had marked everything out, and we were just rough cutting it out with a saw to get as much of the material off as we possibly could in the beginning. And here it again was planed away with an electric plane down to the line. We actually cut along the line, first of all, with the saw, just to give us an indentation mark, and then we just kept basically hacking away at it with the planes and with saws until we got as much material off as we possibly could. Now you can see there, it's beginning to take shape. So it's beginning to come to a feather, what's called a feathered edge at the end. And so there now. Once you have all the roughing out done, the traditional method is that both joints are placed on top of one another, and they're actually they're done by hand, finished off. So what I'm using there is a thing called a jointing plane, which is it's over 2 foot long, and it ensures that you have on both the y-axis and the x-axis, you have it's basically a straight edge, and that everything is nice and flat, and that when it mates together, there are no gaps, because that is one of the big problems with gluing if gluing or laminating something, is that you would have air pockets. So try to avoid this. So this is all done by hand and by eye, and it does take a bit of time, but it's well worth it. And if you're working with a nice timber like Douglas fir, actually it is quite easy, and of course sharp tools. So again, this is a close-up. I was finishing it off here with a smoothing plane, and just to get and you can actually see the grain of the timber there. It was a extremely nice timber, and we were quite happy with it. It was very easy to use. Now there it is. So that's various stages of the planing. Is he holding the plane correctly? No. No. Okay. No. So this was a final scarf, and you can see actually the grain detail there of the Douglas, and it is a very beautiful timber, and it actually varnishes beautifully. It comes up beautifully when varnished. Okay. Now, the most important thing of any gluing operation is a thing called dry fitting, where the components are fitted together dry before you glue, because once you commit with the glue, it's very hard to turn back. So this is here. So the initial clamping, and I think everything at this stage was good. We were happy with it, and so we were ready to glue. And again, there it is, using the glue, which I will discuss later on. So again, loads of clamps. You can see this glue, this polyurethane glue, actually foams up when it hits the air. And now people say it's gap filling, but however, I prefer not to have any gaps to fill to begin with, and it eliminates it. But it's a fantastic glue, and as you can see, that's an extremely strong joint. So that piece of timber is now over 40 foot in length. And now, here's the product placement. So now, this is what we used. So it's a 501, and it's a polyurethane-based glue. The beauty of it is, you look up in the corner here, water resistant, and that was the big thing for a mast or for anything in maritime. And this glue is maritime, can be used in the maritime industry. And I have to say, it was the first time I used it. I have to say, hand on heart, I'm really, really impressed with it. Extremely impressed with it, and its strength is unbelievable. I am highly recommending it. So we'll talk about it more later on. I will be taking questions on these afterwards. So now, this was the scarfing configuration. So there you can see one section was in two pieces, and the other section was in 3 pieces, to ensure the scarves were well apart. You don't want 2 scarves over one another, on top of each other, because we were very concerned about creating weak points in a mast. And a mast, like something like in a Galway Hooker, carries a lot of pressure. So we were extremely cognizant of this all through the process. So our design emphasized this, that try and separate the scarves. So so this is actually a copy of the original little drawing I sent to Paul in the beginning. And again, this was an advice from Joe Piddington. So now, okay, so now, okay. Now, how did we do this? So at this stage, we have two pieces of timber that are 40 foot long, 41 foot long. They're 10, bear in mind, at this stage, they're 10 inches, 10 inches wide. Okay. They're 10 inches wide, and they're still 5 inches deep. Now, to make them hollow, what we did was we actually cut a trench. We cut a trench out of the middle of the timber. And one of the things we needed to be certain of here is, if you can see in the picture there for my thumb is, that we had plenty of gluing area left over, while still removing a lot of timber, that we had an ample gluing area, because gluing, the bigger your gluing area, the stronger your joint. So it's a bit of a compromise. If you have a large gluing area, you may not have a large opening. So we had to compromise on that. We had about 2.5 inches there, if memory serves me right. Now, this stuff was cut. I initially cut this, and I will explain in the next slide how this was done. We cut these with the saw, and we actually removed them with gouges and chisels, and actually planed them off with a small rounded plane towards the end, just to make it nice and clean. Now, this is where the beauty of AutoCAD comes in. I was able to, at each section, this is at the base, down at the deck level. You'll see it's 10 inches. The mast is still 10 inches across, and I was able to calculate out and draw out how the section would look. So what I did was, we took measurements at 1/2 inch intervals, as you can see there, and I actually marked these out on each piece of timber, and we cut down with the saw. So this ensured that we had a 95% success rate, and that you were straight down to the line, and it ensured extreme accuracy. And as you can see, because the mast tapers, the measurements were different in every section. And again, this is the beauty of something like AutoCAD, that it does this automatically for you, rather than having to go to all the trouble of draw it up on paper and draw it full size and all this. So, the accuracy of AutoCAD is extremely high. So we had sections there, and these are the final two sections at the top, and obviously at the obviously up at the hounds, where the stays are tied, we left that solid, and we left the mast solid underneath the deck. Well, almost solid. There's a small little opening, which I will explain that later on. Okay, so there you can see on the left hand side, you can see after the sawing, you can see the lines, and you can see all. So this stuff came out quite easy when it was sawn out and then planed. We also put some preservative inside, ensuring we didn't get it on the sides of the timber that was to be glued. Now you can also see there in the picture trunking or conduit, which was supplied by Paul, and the reason we had this was that this is where all of the cables travel through this. And so everything is nice and tidy. One thing, perhaps, if I was doing it again, and hindsight is a great thing, and every design process is an evolution and is a lesson. I would probably stick a bit of foam around expanding foam around the conduit in a few places, just to keep it straight and to keep it from touching the sides of the mast. So if ever any moisture comes down, that it would never be touching the actual sides of the mast. However, this is as I said, this was a learning curve, and this was an experiment to a certain degree. And now this is product product placement. You can see the glue left in the picture. So now you can see both sides. In the right-hand side, you can see both sides of the mast ready to be glued up. And we allowed, if you see on that picture on the right-hand side as well, you will see that there's a little trench running all the way down to the base of the mast. Now, this was done for two reasons. I remember speaking to a guy years ago, and he told me that he built a surfboard, or a paddle board actually, and it was hollow, and he had to leave an expansion joint in it, an expansion valve, when he used to carry it around in the car in case it would explode, because apparently the glues could give off a gas, and he was afraid it could explode. So bearing that in mind, I was saying to myself, the chances of this happening are more than likely low. However, I said, probably not. Let's not take the chance. And secondly, I was working on the assumption that a bit of moisture would eventually get inside the mast. And if it got in, we needed to make sure that it's somewhere to get out. So that's the reason that's done. And if you see in the second picture there in the middle, conveniently beside the tube of glue, the bottle of glue, there's a little, the trunking comes out to the side. Now, this was deliberately done because on the Crónán, all the cables come out just underneath the deck and can be plugged into all the electronics at this point. So it makes life very easy, and it's also makes things much tidier. So moving on. Now, this was the big thing. This was the big day, gluing up. Now, we did an initial dry mock-up to ensure everything was okay, and that everything was okay, and everything was as it should be, lined up, and everything was perfect. So then one Sunday morning, we got, I think it was 8 people together, and we actually made some clamps. Paul and Jerry made some clamps actually with bars of iron and threaded bar, and so they were prefabricated. We had all the clamps. We placed them at roughly 1 foot apart, and some G clamps, which we also had, and we got 8 people into the workshop on Sunday morning. And the one thing about this glue is it's fantastic in every way. However, there's a thing called an open time, and open time on glue is actually how long the glue is viable, or how long you can leave it exposed to the air before it becomes inert and it doesn't work. In this case, this glue is, it says on the bottle 20 minutes. So we said to ourselves, we have a big job here. We really need to do this really fast. And I must say it was run like a military operation, and it went to perfection. I think we used about 3 bottles of glue actually. And we had it all done, glued up in 13 minutes and tightened up. And as you can see from the picture, this was taken from the attic of Stefan's workshop. You can see the size at this stage, the size of the balk of timber. So now what you have there is you have a piece of timber that's 10 by 10, and that's 41, that is tapered, but it's 41 feet. It's tapered in one plane, but it's 41 feet in length. Well, actually it was 42. We left it a foot longer in the beginning. So this, it was by no means an easy task. Now, when you get to this stage, you come back to the realms of traditional mast making or spar making. You basically now have your balk of timber or something resembling a tree. And so everything after this goes back to tradition and goes back to mats. And there's a certain formula for making something square, making it round. So I'll show that in the next few slides. So now this is here again, just to show the size, the sheer size of this. If you look at the picture on the left-hand side, you'll actually see where the trunking comes out through the top of the mast. And we had to be very conscious of this afterwards, that we didn't lose it back in through the mast. So we actually used to ensure it was tied off on all occasions. So it went very well. We used Guinness kegs as our scaffolding, and also as to level everything out, because thankfully the floor in the workshop was very level. So this made things very easy. When gluing up, you need to ensure you do have a level surface. If not, there will be repercussions afterwards. So now the theory. How do you actually make a mast? What happens? So now, to make something round, believe it or not, in the beginning, you must make it square. And I know this is a contradiction, but you must make everything square and ensure that everything is at 90 degrees. And then everything after that works off center lines. So once you have something square, remember you have 4 sides, something that's square. Then the angles are divided. So your 90 becomes 45, your sides are divided by 2, and then you have an octagon. Everything becomes 8. At this stage, you can actually see where something is beginning to become round. Now, to get to these measurements, I'll show in the next few slides how I got to these measurements. However, this is the theory first. Then, once you go to 8, obviously the next one up is you double that again. You go to 16, and each time you increase the sides, you decrease the angle, the internal angle. So now this is at 16. At 16, it's it is almost round. You can see the corners are beginning to go. So then you go to 32, and at this stage, depending on the size and the diameter of the spar, something of 10 inches at 32 sides will definitely be round. If it was a bigger spar, you may have to go to 64, but this would be something that would maybe 2 foot in diameter. You'd be talking something very, very big. So then once you're at the 32 sides, you basically are round. All the corners come off, and once the corners come off, everything is round, and you're back to 360 degrees again. And that's the theory. Now, how do you get to these stages? So this is again where AutoCAD comes in and does everything for you, does all the work. So at each section along the mast, I took a cross section, which is basically a width of the mast at a certain section. So for example, section 1 is 7 foot from the base of the mast. It's actually above the deck in this case. And you can see the octagon is 10 inches. The mast section is still 10 inches in width. And working off the center line, you will see there that each side of the octagon are 4 1/8 inches in width. However, if you're working off a center line, they are 2 1/16. And this made life very easy to have this drawing because it enabled 3 or 4 of us to be marking at the same time. And then you move on to section 2, and again, it's the same thing. So just because the mast is actually tapering in the upwards direction, your cross sections will be diminishing on each occasion. But however, you have all the information, and it's just a matter of basically plotting all the information. And again, these are sections 4, 5, 6, and 7, which 7 is the very top of the mast. So the top of the mast was 5 inches, 5-inch square section, then became an octagon, and it is 5 inches in diameter in the end. Okay, and now this is again where you move on to your 16s, and again you have the exact same process. Everything again marked off your center line. You can see the center line there; it's the broken line, and so on the 16th side, each side was 2 inches at the station 1, and of a half of that was 1 inch, obviously working off a center line. So this ensures accuracy all the time. So when I say center line, we would use a chalk line to draw the line, working on the basis that the shortest distance between any 2 points is a straight line, and so on. Now, this is a picture of the timber or the mast section being square. At this section time, we had marked off the octagon, the sides. So I was able to set the saw at 45 degrees and cut them with the circular saw. And I merely finished it off down at the bottom with a handsaw just to clear it off. You can see also in the left-hand side, you can actually see the scarf joint. And if you look closely, you'll see the scarf joint, and you'll see that the 2 pieces of timber are slightly different. Even though they're the same species, they're slightly different. So it gives a nice visual. but it also shows it shows how well the joints actually glued up, and you can see the center line in the middle where they've glued up, and like the glue line is fantastic. It's just what you would want. It's nice and small. There's two things that can happen during gluing. You can have excess gluing, which is too much glue, or you can have a thing called glue starvation. And glue starvation basically means that the joint never has enough glue inside it, and therefore may fail. So it's a fine line, if you pardon the pun in this case. But if you have a nice, clean, crisp line, if it looks right, then it is right in this case. And now, this is the octagon completed, the 8 sides completed. And you can see me actually planing them down here with an electric plane. And if you're looking straight in, you can see this is looking from the top of the mast downwards. You always work up from the base. And here you can see, again, there's loads of pencil marks on this. This is when it's become 16 sides, and I'm actually planing them down with the electric planer. Now, there was a lot of planing. We took bags and bags and bags of shavings out of there. And then once you start coming to 16, you start going to 32 on the next one, and then all of a sudden everything is round. And after that, it is finished with various degrees of sanding. The initial sanding was actually done by belt sander, and up and down with the belt sander through the grits. Started out with 80, then 100, then 120, up and down until you ensure you have a very, very fine finish. If you look at the picture here to your right, just where the little knot is, you can actually see where the scarf joint is. The scarf joint is actually there. But now it looks elliptical at this stage because of the curved surface of the mast. And now this is final varnishing. So before the final varnishing, we sanded everything by hand, and we actually made up some sanders where we used pieces of timber and we glued actually fine sandpaper to them. And we went over it by hand, and until it was as round as we could possibly get and as smooth as we could possibly get. And actually Jerry had the idea of hanging it off trestles so we could varnish. And I can't remember the name of the varnish we had. I know Paul got it. It may have been international. It was a very fine varnish. The one thing was, at the time, I remember the weather being a bit cool for varnishing. So these are obviously things to consider for the next time. And we went with tradition. The top of the mast is painted white, going with tradition. But you can already see with the first few coats of varnish, the Douglas fir really does come up beautifully when varnished or oiled. And again, this is more of it, more painting, and you can. There's barely a joint visible there. So to the untrained eye, from a distance, that mast would look as if it's a hollow, if it's a solid mast. And again, here's after sanding, and so also ensuring we used a drop cloth tarpaulin underneath the mast just to stop everything dropping on the floor, varnish and everything dropping on the floor. And you can see there that we were quite fortunate. We had a very, very nice piece of timber. And now, ironwork. Paddy made this piece, and Michael O'Shrahan actually in Clondalkin, who was teaching Clondalkin school at the time, where I was teaching myself, and who was involved with the initial building of the Naomh Crónán back in the day, actually made the belaying pins from a piece of brass. I think it was a piece of brass. Was it a shaft? I think we had that was left over from an engine. But he made a beautiful job of them, and coupled with Paddy's beautiful work, it really does look nice. Now, this is it. This is the mast in the boat, and this was the moment of truth. So there you can see the mast. First of all, it was straight. That's the most important thing, that it actually is straight, which it is. And the other thing, which we were pleasantly surprised, was we obviously knew it would be lighter than the original mast. However, we actually didn't know But as it turns out, at a conservative figure, the original mast was 1.2 tons. What has replaced it is half a ton. It's 500 kilos. So that's more than 50%, 60% reduction in weight. And the effect on the boat was instantaneous. And during sea trials, you could see instantly on the boat was responding more effectively. And because it wasn't weighed down with all this extra weight, definitely, I can definitely see why yachts and all these high performance boats go with hollow spars. You can definitely see the logic behind it. Now, this is it. So now this bit of film was taken actually from aboard Adrian Spence's boat, as far as I know, and I think it was, and it shows how the boat did perform, and how she was performing with it. And this was actually last year in Poolbeg Regatta, and
that's all, folks.
And Sinead.
Oh, well done, Donal. That seemed like a really professional finish to a pretty difficult job, I'd say, yeah. But AutoCAD certainly came into itself. There's no doubt about it, yeah.
It did actually. It did. It made all the calculations. It made all the calculations easy. That was the beauty of it, and you knew that everything was accurate, because of that. So I was really delighted with that. So I think it proves the point that there is a place for traditional and technology. Yes.
Donal, did you line up all the scarf pieces so that the grain was running the same way before you glued up?
Yes. We were conscious of that, and actually we were conscious as well. The one thing about natural timber, when you have big blocks of timber, when they're cut in a sawmill, in a commercial sawmill, you do everything called spring, where the timber will spring slightly, maybe to one side, and this is one of the things you always need to be careful of when joining long pieces of timber, to eliminate that spring. So there was a bit of a figuring out in the beginning. Actually, we did have to go through the timber and have a bit of figuring out, but again, we were quite fortunate with what we had, that the quality was good, and the timber had dried, and it had dried without really warping. If I was doing it again, I would probably get the timber at half an inch bigger, and I would probably dress it down to size to ensure absolutely that you were at the nth degree of accuracy.
Tell me, did you calculate the cramp pressure to avoid starting the glue line? How did you manage that?
Well, I didn't calculate it, I'll be honest. Now, I did do a test, actually. I ran it through a thing called SolidWorks. And one of the things on SolidWorks is you can actually, if you put in the material, you can actually do a compression test and a stress test. Now, I did a little bit in SolidWorks, but nothing, to be honest. It was just an experiment from my own behalf. I did it based on what I knew and what pressure I knew. And my rule of thumb is with glue, if you're gluing something, when you squeeze the clamp, if the glue starts oozing out, then usually it's tight enough. That's yeah, and uniformity. Yeah. Uniformity of pressure, I think, is the big thing on something like that. That you have equal pressure. So that's why we use those clamps. I actually remember reading a book years and years ago called "How to Build a Wooden Boat" by a fellow called Edgar J. Marshall, and he had actually clamps like that made, but they were made out of oak. And he said at the time what they did was they ensured equal pressure on both sides of the spar. So we used metal ones, and the beauty of it is we have a full set of them now, which we can use down the line again when needed.
Very good idea. The last question from me, Paddy's ironwork, it looks beautiful. Did you put it straight on the timber, or did you put leather underneath it or anything like that?
No, we put it straight on actually. No, we didn't use any leather actually. No. Now in the West, traditionally, leather wouldn't have been used actually. No, probably on something as nice as what we did. In hindsight, that probably would have been a good idea. However, no is the is the short answer.
Well, it's a stunning piece of work, I must say. I thoroughly enjoyed watching it. Thank you.
You're welcome.
Donal, if I might just ask you, was the timber homegrown timber, or was it imported?
It was actually homegrown, Cormac.
Was it?
Yeah, yeah. And we were very lucky. We just when we went there, because a lot of the time, as you know, with Irish timber, it's hit and miss. But he did assure us at the time that it was a high quality. And I actually bought a stick myself there for boat building. And when that was sawn, the quality was very, very good. I was extremely pleased with it. I have to say, it's some of the nicest timber I've seen in a long, long time.
You actually made a new hollow gaff as well.
That's right, we did.
In addition to the mast.
We did. Now, again, I used the same method. AutoCAD again was used, and we used the same exact method. And second time around, it was actually easier. Plus, the beauty of the gaff was it was so small that it was very easy. We could do that in just 2 pieces, and that wasn't a problem. Again, there's lots of things you learn along the way. There was lots of little lessons we learned along the way. I initially thought I may make the scarf joints using a router and a sled. And when I actually tried it, I actually went to the trouble of building a sled, and I actually found that doing it by hand was much quicker and actually just as accurate.
Sorry, just to finish off, if I may, you actually used you normally use water as a catalyst with the Puricol glue. Did you do so in this instance?
There was no need, because this glue, the moisture in the air and the moisture in the timber acts as a catalyst, and so we weren't using kiln dried timber. We were using air dried timber. What I would imagine was between 12 to 16 at that stage in moisture content.
Before you go away from that there, sorry, can you hear me there?
Yeah, I can. Yeah.
Before you go away from that, Cormac, I must mention that Cormac made most beautiful pair of jaws. And I hope at some stage you'll have pictures of that to show us. The first set of jaws for the Crónán were hewn out in my garden in Belgard from a windfall of ash there. But on this occasion, Cormac made the most beautiful pair of jaws. And we'll get photographs of that up sometime, Cormac, I hope.
Thank you.
Donal, taking that amount of weight out of the mast, did the recovery rate of the boat from a gust, did you notice the difference?
Yes.
When you go over sideways and that, what difference did it make to the way the boat behaved?
It did. I'd say the boat came up a plank in the water, and the boat was definitely livelier. You could actually see it. You could feel it in the boat that it was much livelier. And I suppose when you think about it, we're saying there was 1.2 tons there originally, but you were 1.2 tons up in the air. Like that creates a huge pendulum action, which means then that you had to counterbalance that by extra ballast. So when you take that out, like it makes a huge difference. Like I could see if you had this put onto something like, we'd say for example, like the Tony, which is an absolute racing machine. I would imagine. I would love to see it as an experiment actually and time it to see how it would react, because I'm certain it would increase speed by at least a knot or 2.
Have any of the racing fraternity down in the west of Ireland taken a leaf out of your book yet, Donal?
No, this is a very
purist still.
This is a very contentious issue down in the west of Ireland. It's hollow. As part of the Hooker Association ethos and 10 commandments, hollow masts aren't allowed. There was one incident years ago, however, that was thrown out, shall we say? So it's they haven't. Laminated. A lot of guys are actually using laminated masts in Connemara at the moment. For the simple reason, lamination gives you 2 things: strength and also ease of transportation. the days are gone where you can actually go out into a forest, cut down a tree, and actually try and transport it in. Like those days are gone. It's too many complications, too many, and people don't have the skills. There are people that, we are losing the skills of people being able to go out and actually select a tree and,
Donal, did you do anything about the balance of the boat, weather helm and that? I moved my mast forward a foot, and it made a huge difference to the balance of the boat. Did you look at that at all?
It's an ongoing process, to be honest. We genuinely did not know how this would work. When we did this, we knew theoretically it would work, and we knew we could do it. However, we didn't know. Weight-wise, if I had been asked beforehand what weight the mast was, I would say if you could have got 300 kilos off, you'd have done very well. So it was a learning curve after that. We just basically had to trim the boat accordingly afterwards because she did come up in the water. So we had to literally trim accordingly. So it still is a learning curve, and I would imagine it'll be more interesting this year because we're a year further on and probably a year wiser. But we'll also see how the mast reacts, being laid up for all winter.
But you made no effort to change the balance of the boat by moving the mast forward or aft, no?
Well, we took out some ballast, Sean. We took out ballast because we had extra ballast we didn't need because of having the mast in there.
That has only come out this year, Donal. We haven't tried it with that yet. We've only taken that out now.
And is the weather helm the same as it was before?
The weather helm is pretty much the same, but the boat can take a lot more. You can give it a lot more sheet, but you don't have to dump the sheet as quick.
Okay, all right.
With Donald's permission, I might just perhaps tell you something about the history of hollow mast and spar making internationally. It began in Dublin. A firm in Dublin were the very first to do it and provide masts and spars all over the world, hollow masts and spars. They were called Hollways, and they were in existence from about 1870 till 1930. They were in Windmill Lane, just off Sir John Rogerson's Quay in Dublin, and they manufactured hollow masts and spars for most of the great big racing yachts in the end of the 19th century, such as the Royal Yacht Britannia and the yacht that belonged to the Kaiser Wilhelm called the Meteor. But they also made the masts and spars for a great many of the Herreshoff's racing yachts that took part in the America's Cup races. They were world renowned, and they had what they called their own particular patent cement, whatever glue that they used. They used American timber mostly, and it was guaranteed that it was a type of spruce that was guaranteed not to have any knots. But they also did, they were renowned boat builders. They built a huge amount of yachts. They built most of the Dublin Bay 21-footers. They built the only station lifeboats that were ever built in Ireland, where the Dunleary in Kingstown and the Charles Whitten, the one that Warner brought down the canal and onto the Barrow. That was built there by them also. It was in Clogherhead originally. But they also built a huge amount of motorboats that took part in racing regattas around 1900, speedboats. So you were carrying on a very, very fine tradition, Donal, although I think the mast was actually made in Wicklow.
This is it.
So thanks for a very, very fine presentation.
Thank you. I would say one thing about actually that we're fortunate that we live in an age where actually glue technology has come to is at such a pinnacle. Like modern glues, modern adhesives are so good, compared to, for example, years ago people would use cascamite, and I've used it myself. But after 20 years, cascamite could actually fail, and spars could actually fall apart. Whereas these new adhesives are absolutely fantastic, and the amount of technology that's there and the amount of knowledge that's there is unbelievable. And I think lamination is the way forward. I think most, even in the West, most boats are going to be in the future going to be carrying laminated masts because number one, you can ensure a quality of good timber, and number two, strength. Strength to weight ratio is unsurpassable compared to what you will find in natural timber. Like one of the problems with natural timber is if you go and select a tree, until you cut that tree down and you actually start chopping it up, you have no idea if there's anything inside it. Like I remember years and years ago making a boom, and we cut it and squared it, and by the time it was square, we discovered there was a big spot in the middle of it, and it had to be abandoned and start all over again. So that, you know, so there's pluses and minuses, I would imagine.
Maybe Donal, if you don't mind, if I could just mention something there about the adhesive at this stage, and thank you very much for pointing out that the modern day technologies now have come a long way. And one of the things with the adhesive that you used on your mask is it doesn't just bond the two pieces of timber together in the scarf joint. During the curing process or the cross-linking process with the reaction to moisture, it also chemically anchors itself onto the wood grains of the timber you're using. So it's not just a mechanical bond, it's an actual chemical cross-linking bond that results in the final glue joint. And because of this, you want a very even glue line, which you have mentioned in your presentation quite clearly, that even pressure and even stress levels during the cross-linking or curing process is critical. Because if you put any stresses on the joint during that time, you create very micro fractures in the glue joint, which at the end of the day is going to lead to a delamination or something in some time to come in the future. And what you've done there was exceptionally professional. Also, what was good to see was when you were carving out your scarf angles to put together, this was planed and not sanded, because bonding sanded wood together will always result in a much weaker bond strength than a planed exposed timber piece that you're bonding together. Because if you sand a joint before you bond it, you're basically bonding to sand dust that's been forced into the little grooves and nooks of the adhesive, and that's going to be the first thing that's going to reduce the bond strength. So all in all, everything you did, you put me under a bit of pressure here because I didn't realize you were a teacher. So I thought you were doing all of this by just hope to the gods. But anyway, you knew what you were doing. So well done. Great presentation.
Thank you. Thank you.
Donal, you did consider bird's mouth joint at some stage. I know that it gives a much larger glue line than the method you used. Why did you abandon that idea? Or
I suppose it was twofold. Number one, the method which we did use, and upon Joe's advice, was actually easier and ultimately stronger, in my opinion. Also, I think we could have made the bird's mouth. However, you would need a high degree of accuracy because you'd have staves that would be you'd have 8 staves that would be scarfed at 40 foot, but would also be tapered, and you'd need a high degree of accuracy. And you would probably need something like a large rotor table or a profile cutter or something to actually ensure the angles were 100% correct. Now, it is doable. It is doable. However, the one thing also that I considered afterwards was down at the base, you're working on something like a bird's beak being actually round all the way from the base to the top of the mast, whereas we had a square section. So we would have to have glued this square section onto it again, which we thought was a lot of trouble and was perhaps somewhere where moisture could land. So that's the short of it. Yeah, I think a boom would be ideal. If I was to do it, I think a boom would be ideal to do in a bird's beak.
Yeah. Yeah, because it was round all the way and the same diameter all the way. Yeah.
Yes.
Yeah, I'd love to do one and see what it's like.
Donald, in 1983, I had 2 masts made, 152 feet, and the mizzen was 36. And I got it made out of Sister's spruce. A man in Dunleary, John Brennan, I think his name was,
That's
made
right.
it for me. Yeah, absolutely fabulous. Something the way you looking at it there now, looking at your one tonight, made something similar. Only mine was box sections. They were about 10 inches by 6 when they were finished.
Yeah, well,
But,
actually, I have a
they're still standing now, and they're perfect.
on my own yacht. Actually, on my own yacht at home, my main mast is actually a square section, and I am considering making it over the winter, making a new mast actually for myself, and it would actually be easier. In one way, it is easier to build it in a square section because you don't have to go to all the trouble of rounding off and everything. The big work for us was actually rounding everything off because you were on the big sections of timber, and again, basically that doesn't change from the eons of time. Like to make something round, you make it square, and it's all mathematical. But again, down to the glues. That's the beauty of it. Nowadays, you have all these options of just being able to do these things. It's fantastic.
One other point of interest, Donal, was you mentioned you left an expansion joint in the design,
Yes.
which wasn't exactly critical, but pretty good practice, because during the curing process of the adhesive, when the isocyanate in the adhesive reacts with the moisture in the wood and the atmosphere during the curing process, the byproduct that it gives off is CO2 gas, carbon dioxide. And if the wood isn't porous enough to accept the CO2 that's emitted, it can't go any other way except escape out the sides or escape through the easiest route possible. So if you give it some area to escape during this curing process, it's always better. But once it's cured, at this point in time now, with the mast as it stands, all of that expansion and emissions of CO2 are finished. So if you haven't got any cracks or explosions at this stage, you'll find you're good to go.
Good.
Yeah.
I wonder if I might ask Bradley a question. What's the best thing for getting that Puricol glue off your hands if you get, Clearly not washing them, because that only makes it worse.
There's one simple thing, because I mean, I presume your skin turned black after a period of time.
Absolutely.
Yeah, you just wait until a new layer of skin comes until it falls off.
Yeah.
Yeah. But wear gloves in future.
Get somebody else
The
to
best
use
will in the world, even wearing gloves, you'll always get a bit.
Yeah. No, there isn't. I mean, just normal acetone or something like that would be okay at the time, but that in itself also dries out your skin and not too good for you anyway. Yeah.
A quick one, lads. Can I ask a question there, Donal?
Yeah, work away.
Can I be excused because I have to go?
Okay.
Thank you for
Are you gone yet?
Hold on.
Are you gone yet?
Please let me finish. Thank you for a great presentation, Donal.
You're welcome. You're welcome.
And some of what you described there, we had that experience. We had that experience with the Naomh Crónán. We changed the mast 3 years ago.
Okay.
You mentioned the famous hollow mast. When that finished up
Yes,
on the Naomh Crónán.
it did indeed. Yes.
and then it finished up like 2 masts.
I heard that.
Yeah. But the condensation down the middle channel, that was part of the problem because they had no escape.
Yeah.
With all that, that's my own rush. I thank you again, Donal, but I have to go.
Okay.
Thank you for a great chat.
You're very welcome. No problem.
See you, lads.
See you later.
Hi all, can you hear?
Yeah.
Yeah, I might just avail of this opportunity of asking one of you learned gentlemen. I have a load show refurb underway, and I'm looking to acquire a bowsprit. I need 13 feet. I'm sure it has to be solved. The top end of anybody's broken spars, I'm asked might do rather than have to start afresh and build one.
Tom, I might have what you need. I broke a bowsprit on my way down to Glandore Classics about 10 years ago off Wicklow and in the overfalls there. And I went into Arklow, and a man on the quayside said, there's a few spars from an Arklow yawl that they built in the Scout Hall. And he brought me down to the Scout Hall, and we I found that they had a mizzen mast there which would suit, and he brought me to a pub where the scoutmaster was entertaining his wife, and I made a contribution to the scout funds and ended up with that mizzen mast, and I brought it back to the boat, and I had a Japanese saw aboard, and I cut it to length and put it on half a day, and we sailed down to Glandore, and we did very well there. And I used that spar for ages and ages. But this year, Barry O'Loughlin built a new spar for me, and I have that mizzen mast from the Ark Royal still here. You're very welcome to it if you want it.
Ah, you're very kind, Sean. I'm delighted now. Mac took the I mentioned it, so I'll give you a buzz later on, Sean. Thanks.
You can say
I
it.
could save some problems.
If you're really stuck, we have a postal telegraph pole that we put on temporarily on the Breckenlass about 30 years ago. Thank you. Where's Joe Pennington? Thanks to Joe. He cut right across us and broke our bowsprit. It was a disgrace. Scandalous.
Joe, I
have a telegraph pole as well. You can have.
Donal, just to thank you for an excellent presentation, but at the same time reminded me of the first mast we made, and Joe Murphy and Ed Ferry no longer with us. We had a great day down in the Canal Basin. I'd say Rings End was covered in shavings for about 2 weeks afterwards. Johnny Healy and Joe Murphy and Ed Ferry running around us, about 12 people just roughing it out by eye, and it got there. But it's, you know, let's remember those old friends as well. Thanks very much, Donal.
You're welcome. Yeah.
Right, has anybody any other questions, or anybody on the scrounge, Tom? Anybody now, like?
Donal is interested in the varnish. Was it Epiphanes that you used, and how many coats did you put on?
Actually, I'll throw that one over to Paul, because I can't remember the name of the varnish.
I can't remember myself.
Yeah.
But if you give me 2 minutes, talk about something else, I think there could be half-empty tin in the shed that I can ask.
You're grand.
Off Johnny. He was on the.
Get off Peter and Sue. Get off Sue.
And how many?
While everyone is on the scrum, I have an offer for all of you boaters. Yeah. I have a Lawrence A65 chart plotter combo, which I just want to donate to whoever wants it. Well, not donate. A couple of pints in the pool bag pub afterwards may be okay, but that's about it when the black stuff is back available again. But it's the chart plotter, cables, the transducer, everything. If anyone wants it, you're welcome to it.
Great.
Yeah, I'm okay.
Paddy Murphy.
Paddy.
Well, I need one. I was told I should have something on it when I'm traveling, and it'll help me then when I go to sleep at night.
Listen, Paddy, you won't need it coming up the Irish Sea.
You can hook it up to the autopilot, Paddy.
Several times.
As we're on the bag, I have a wind vane here for Paddy.
Yeah.
And I'm looking for transport to Dublin for it.
Yeah.
It might be that Tom might be able to take it up when he's bringing up the bowsprit.
Lovely. I would like to say to you, there's no real rush for that. And that would be a topic for conversation as to how you're able to put a wind vane on a ketch.
Great difficulty,
talk
Paddy.
about the wind flow interfering with it and all that, but there is a way of doing it, and I've had a look at it, and there's already 2 boats that have done round the world trips with them on, and I will do it slightly different to them, but basically once you have about 2 or 3 feet, two or three feet of clean air behind your mizzen, you can get it to work quite well.
Yeah.
I'm doing out drawings at the moment for it, and at some stage I'll let you all know how I'm getting on.
All right.
But I suppose I've a lot of work to do, but I have this mad idea that I'm going to put the two masts into tabernacles, and I'm going to split the main and the mizzen, hollow them out, and glue them back together again. Now, glue the main with the main, of course, glue the mizzen with the mizzen, but it'll be a way of lightening the load on the egg white. And I think, like Donal was saying, the performance should improve. Though I'm not unhappy. I'm happy with the performance of the egg white, but I can see that there's an awful lot of weight with the mast and irons up above, and you're saying the momentum effect. She's slower to come back up. She's not as quick as I would like it to come back up. So we'll see what happens, please God. A lot of work ahead. But thank you very much for the plotter. And Donald, excellent show tonight. Really enjoyed it.
Thank you.
And it just goes to show you the way technology can help the old systems. Again, a lot of people are using CAD. A lot of blacksmiths are using CAD to develop structures. Whereas normally you'd put the steel in the fire, take it out. You do drawings out with your chalk and all that, and you would get your dimensions and the volume of your metal that you need and all that type of thing. Well, lots of blacksmiths now are using the CAD to design compound curves and things like that. And they're doing excellent work with the computers and being able then to make up sections and put the sections together at a later stage. doing very good stuff with them.
Well, it's a really powerful tool, you know, and that's how I would view it. I would use it as a tool, and I would have being a traditional boat builder, I would have no hesitation in using modern technology as an assistance, because I think the beauty of it is it guarantees you accuracy. You can draw these things on paper, and you can draw them to scale on paper, but we live in a world of why would you do that? You know, when you can actually have something that you can actually do at the push of a button. And the beauty of something like this is you can actually scale it up or scale it down. Well, in our case, we'd probably be scaling it down if you were using it on a smaller boat. But you know, it gives you all these options, and plus the beauty of it is you can print these off. You have them for posterity, and it's there, and you can actually send. It's a great way of communicating. You can actually send plans to someone, and they can see instantly what you're talking about. It, you know.
Yeah, Donal, thank you for an utterly professional presentation.
Yeah, indeed.
Interesting. I thoroughly enjoyed it.
You're welcome, Sean. You're welcome.
The varnish you were asking about is Hempel Favorite Varnish, which Holyhead, I think the OGA regatta was sponsored by Hempel, and we used to talk.
Is there one for everyone in the audience? Is there, Paul?
It's great stuff, Dad. I can vouch for that.
8 coats on that varnish, on that thing.
8 coats.
8 coats, yeah. Yeah.
Peter Farr, how many cans did he bum off you?
22. 23. I found one more. 23.
Actually, Paul, I think I have a few cans of that which I got from Sue, God rest her. So
yes.
You're welcome to them.
We'll be down for them.
But you can bring home a bellsprit, so.
It's excellent stuff. I've used it. Brilliant.
Yeah, well done, Doom Techie. Thank you very much, Mark.
Thanks, Mark.
Yeah, thanks, Mark. And Donal, that was fantastic.
Donal, thank you very much indeed.
You're welcome, Nicola. You're welcome.
Thank you, Donal. And thank you, everybody, for joining in.